Flying in the US feels like a slow bleed. You build in extra hours, sprint to new gates, sit through temporary maintenance holds, and still arrive late. That isn't a one-off. In 2023, nearly 1 in 5 flights miss schedule. Fares stay sticky because fuel keeps biting, about 30% of airline costs. So, the add-ons never seem to stop. The old system is getting more complex and costly for everyday travelers. Tonight, we follow a different thread. The Tesla Super Electric Plane, a $79,979 electric plane built the EV way, and outline its production plan. Modular airframe pieces, shared pack, BMS, motor and inverter, OTA support, and a real service network. Factory choices and charging rollout would also be mentioned as we test what this could mean for cost and uptime. If you want clear numbers first breakdowns like this, please subscribe and turn on the notification bell so you never miss an episode. 1. How will Tesla cut costs and accelerate production for the super electric plane? Tesla's starting point is a gigafactory system that is very large in scale, highly automated and optimized for modular assembly with tight quality assurance. When that mindset is carried into light aviation, major assemblies of the Tesla Super Electric Plane, such as fuselage, wings, battery pack, motor, and power electronics can be standardized into large modules, each with its own inspection routine before joining a cell line-style final assembly. Because the number of joints falls and every step has clear test criteria, production cost and defect rates go down, while repeatability during scale-up goes up. From that foundation, the practical answer to where to build becomes clearer. Giga Texas has the space and infrastructure for oversized structures and already handles large body projects in automotive, so it can take on airframe work and final assembly. Once the airframe is built quickly and to tight tolerances, the rest of the Tesla Super Electric Plane moves through modular stations similar to Tesla's car lines, which keeps overall schedule stability even as workload grows. The energy modules point naturally to Giga Nevada. This is Tesla's battery hub, where cell pack BMS and pre-processing for energy modules already exist. When the battery pack, BMS, and inverter are standardized into a single energy block that can be tested independently, the airplane plant simply receives compliant modules and installs them into the airframe. The result is shorter waiting time at the main factory, more stable output quality, and lower inventory costs because the platform is shared with the EV business. Global market needs then highlight Berlin and Shanghai. Both sites have demonstrated rapid localization in workforce and supply chains along with high output and steady cadence. When the Tesla Super Electric Plane needs a footprint in Europe or Asia, transferring the modular process to Berlin or Shanghai shortens time to customer and trims logistics costs for bulky parts. A multi-continent footprint also adds supply chain resilience since production can be rebalanced if one site faces disruption. All of these choices create a clear chain of cause and effect. Modular production reduces part count and joints, which cuts defects and shortens assembly time. Shorter assembly time lets a plant process more airframes in the same period, which lowers average unit cost. Once battery, motor, and power electronics are standardized, inspection and in-service replacement by module becomes straightforward, which reduces customer downtime and makes lifetime maintenance costs more predictable. Finally, the scale and reach of the Gigafactory network allow very granular quality control and parts availability. Every module of the Tesla Super Electric Plane carries traceable IDs, test records, and common acceptance criteria across sites. That consistency lets Tesla sustain high volume while holding quality steady. The outcome for users is a lower total cost of ownership, higher aircraft availability, and a clearer maintenance experience. From factory to flight line, every link serves the same goal, which is to make an electric airplane a practical choice rather than an idea on paper. Comment Tesla Giga if you agree that Tesla's Gigafactory network is the key advantage that will let the Tesla Super Electric Plane take off faster than its rivals. 2. How will Tesla's powertrain and energy network shape the Super Electric Plane? The technical foundation Tesla has built in electric vehicles can transfer directly into light aviation in a way that is easy to follow. The core is a standardized stack of battery pack, BMS, motor, and inverter that has been proven at scale across hundreds of thousands of vehicles each year. That scale matters for the Tesla super electric plane because it turns complex systems into repeatable modules that are already known to work together. Efficiency is the first pillar. A Tesla electric car reaches an overall efficiency of about 87 to 91% even after accounting for regenerative braking. Modern electric motors typically run around 90% or higher. Compared with an internal combustion drivetrain, far less energy is lost as heat, which means the same electrical energy can push a light aircraft farther or carry more useful load. For the Tesla super electric plane, less waste translates into more flight minutes for every minute spent on the charger. Noise and smoothness are the second pillar. Electric propulsion avoids the cyclical explosions of a piston engine that burns a gas. So most sound comes from the propeller and airflow. A certified electric trainer, like the Pipistrel Velis Electro, reports about 60 dBA in training use. That is not a target for Tesla, but it proves what is achievable. Pair a high-efficiency motor with a well-tuned inverter and clean aerodynamics in the Tesla style. And the Tesla super electric plane has a credible path to quieter hops that reduce fatigue for pilots and passengers. Energy infrastructure is the third pillar because it sets turnaround time and cost per hour. Supercharger V4 in North America has been announced around 325 kilowatts and is tracking higher as deployment expands. High-power sites shorten stops between legs, especially if Tesla introduces adapters and clear procedures for general aviation. Where the grid is weak, a megapack can act as a fast buffer that dumps energy into the aircraft and then slowly recharges from the utility. Powerwall 3 can handle auxiliary loads and scale in small steps. Reference specs list 11.5 kilowatts continuous per Powerwall 3, and megapack output at the factory level is measured in tens of gigawatt hours per year. With more than 5,000 public-use airports in the United States, sensible placement means the Tesla super electric plane can turn quickly without relying only on strong grid points.